ahead and introduce myself for those who may be on the line that aren't a regular part of First Nations Launch. So I am Christine Bowles. I am the Assistant Director for Wisconsin Space Grant Consortium and the Project Director for the First Nations Launch. We are in our 11th year and we're very excited about this new program that we've started here with First Nations Launch, doing our virtual workshops. And I am going to introduce Orson John. Orson is one of our First Nations Launch judges. He works at NASA Goddard, and Orson is Navajo from New Mexico, Dene, and his job at Goddard is in reliability and engineering, and so he's in the reliability and risk assessment group. So I'm going to let him introduce our speaker, and then we are going to go ahead and get started. We are recording this presentation so that we will have it available afterwards for your reference.
Awesome. Thank you, Christine, and welcome everybody. Ya'at, hello, greetings. My name is Orson, and today we actually have our guest speaker who is going to be presenting an overview of project management. And today we have Dr. Juan Roman, who is our Deputy Director here at Goddard Space Flight Center of our Engineering and Technology Directorate, or our entire Engineering and Technology Division. So Dr. Roman, welcome.
Thank you very much, Orson. It's a pleasure to be here with you guys, with everybody. So I am very honored to be able to provide you an overview in terms of project management, and that's going to be divided in several areas. This is a very large topic, widely used in industry. We use it for the development of our satellites and our rockets, but we are going to give you a very short version and try to compress, a whole semester class into 1 hour. We will want to answer your questions, but because of the limited of time, we will ask that you write the question that you have, take notes, make sure that you know what page or what section you are, and then you can contact us later on. We're gonna do a couple of pauses and kind of ask for clarification, and then we're gonna continue. But do not be shy, please. You can contact Orson or myself later on. Send us an email. We'll coordinate with Christine, and our goal is to answer your questions either during the presentation or at the end, or even later at another time. And throughout the presentation, Orson is my partner in crime. So what I'm going to be doing, I'm going to be describing the topics and trying to make some reference, but Orson is experienced with the FNL process, so he's going to highlight certain aspects that you should be able to go and rely on, or at least pay greater attention, or leverage that knowledge to your project. So we're going to try to make the connection back and forward as much as we can. Orson, do you have any opening remarks?
I'm just excited. I think that this is a very important topic, especially for all the First Nations launch teams that are participating in both the Mars and the Moon Challenge. And I believe that today's topic is fundamental in making your launch a success. And so we look forward to giving an overview. If you have questions, we'll have time at the end, or you just email me, or you can write it in the chat and we could answer it from there at the end.
Okay, so next chart, please. So very briefly, I just wanted to say what is the NASA vision and mission. And our goal is to discover and expand the knowledge for the benefit of humanity. We're all are in this together. So that's a very noble goal. Here at the left, you can see a picture of the the successor of the Hubble Space Telescope, which is the James Webb Space Telescope, which is we're very proud of that telescope that we're building. But let's proceed. Next slide. So we are going to make available a video so you can know a little bit about Goddard Space Flight Center. So we're going to get that video to you later on, since it's close to our heart. Orson and I have been working here for some time, but that will be for another time. Next. So basically at Goddard, throughout NASA, and in many areas of industry, the work gets accomplished through teams, and teams are very important. Teams and projects. You form a team, and then that team has an objective, has a goal, basically a common goal that drives the team together. That's the formation of the project. In this case, there are going to be many groups of you working together for the individual that you're in your competition for the First Nation. So we consider for the benefit of this presentation, we consider that your team. You're interdependent. That means that you rely on each other to help achieve that common goal that you have in your team. You have complementary skills that you bring together for the benefit of the entire project. What is a project? The project is a time-defined activity. So in this case, your project is a successful launch of the engineering challenge, which is the Moon Engineering Challenge or the Mars Engineering Challenge. And when is the end date? April 24th is the day that you're going to be going to the planned destination with your rocket, and either you have developed your system for the Moon Challenge or the Mars Challenge. So you can see that from now until April the 24th, that's your time frame. That's your time-defined process. Now, there are cost control because there are some limitations. I wish that we didn't have problems with money, but in anything that we do, there are cost limitations. There are scope limitations. You need to rely on certain specifications, certain requirements that you need to meet with the challenge. So those are important. So our goal here is to bring all those things together so you can manage, plan, organize, and implement your project, and even more, control it. So you know that you'll be ready for the April the 24th.
That is correct. And we know that this process has already started. We just finished up preliminary design reviews, and you've all presented at your virtual presentations, and you have submitted your reports. And so this effort and this workshop should enforce us to organize and to implement and to control. This is essential for us moving forward.
Okay, next slide. In order. Oh.
We lost the camera here.
We lost the camera. Can I, I think that we just select the wrong camera. Let's, which one? Oh, camera system. What camera? I'm sorry, a little bit. Okay.
We see you now, Orson, on your screen.
For some reason, I don't know. I have to apologize. The setting, and I don't know how to do it, but I just all right. They see it. I just bumped my my keyboard, and it changed the camera. So my apologies. But we'll continue since you guys are. That's why we have a backup. Always be prepared.
Always be prepared. Exactly.
So let's talk about project management, project and project manager. So again, the project has a start date and an end date. And the project management is basically the overview that we're going to give you. So provide you the tools that you can utilize your team in the most effective way. That you can coordinate the activities and you can basically be successful at your activity. Now, one thing that I Most likely you already have, but as part of your team, I will recommend that you have a team leader. In this case, it will be like functioning as a project manager. I will anticipate that all of you have already a team leader. So for this particular presentation, that team leader, it fulfills the role as a project manager. And that project manager, the main responsibility is to provide the vision, the motivation, and coordinate the people in the most effective way to achieve the role.
No, yes, that is absolutely right. So each of you have each team has a team leader, and maybe our team leaders are listening today. So you will be serving as a team leader. You'll have aspects as you're in this role, you'll have different aspects that will more or less involve areas of project management.
Yeah. Next slide. So very briefly, at NASA, everything that we do starts with science and ends with science. But it's not only that. You have to break those activities into pieces. You know, once a scientist conceives an idea, then you have to come up with a design, build it, test it, launch it, operate, analyze. And once you analyze that data, then you share it. So to a certain degree, you have to do the same thing. You have your moon challenge. So now you have to conceive the idea. How do I going to package those eggs and drop them from a very high altitude without breaking them? You have to create a design. And then that design, you're going to be going through this life cycle process in order to make it happen, and then get to the point where you launch, and then you take the pictures, you know, operate, and then analyze it, basically get the data, or were you successful? So this is the NASA project life cycle at very high level, but we're going to focus it more relevant to your activities. But I wanted to highlight, if you go to the next slide, at NASA, the project management is divided into the different phases. Each phases has a different milestones, and they have a different design reviews. You know, also mentioned that you already have done your preliminary design review. So next you will go to the, to the critical design review with all the details before you start building your stuff. So that's basically what the same thing that we do on a larger scale, at a more complex scale. Why we do this, you will ask. Well, it's important to organize the work that you're doing in a way that you can track it and then you can manage effectively. And that's what the whole purpose of the project management discipline is, to bring all the resources together so you can leverage them in the most effective way, and don't waste money while doing it. You can say time is money, then don't waste time in order to do that. Next. So here we're starting to get into the nitty-gritty. So here we're talking about the schedule and its purpose and function. So schedule is just a tool that the project manager or the team leader is going to use to interface and organize the work. It integrates, and the chart says integrates a subsystem, task, and activity into a logical flow. Say, for example, for the first nation launch, you need to buy a rocket, or you need to buy some material. You need to maybe buy a camera. You need to, so you need to take in consideration those things. There are requirements as part of the guidelines that you have to establish some activities and tasks. All of these things take time. So you need to support the development of a time-phase approach so you can identify those tasks, break them down into the components that you need, and then organize them into a way that you will be ready, and not only ready for April the 24th, but ready a little bit ahead of time, because you never know when you're going to run into trouble.
That is absolutely right. And each team, we have our student competition handbook, and that competition handbook is really a guideline that puts dates or items on the schedule that each team must meet. And so going into this competition, assembling your rocket and purchasing your kit, all of those components that make up the kit, from the motors to the booster section to the airframe to your avionics to your payload, and all the necessary components that are needed to meet your specific challenge, whether it's the Moon Challenge or the Mars Challenge, all of these items must be identified up front. And so these types of activities, from what items need to be purchased or what items you may have in inventory, these items are essential for you to take into consideration, because April 24th is right around the corner. And it's important for us to start to put these items in a timetable. Not only that, but also put together on this timetable specific objectives, saying that by this date, I will purchase these items, or by this date, I will have these items already complete. And not only that, but it's important for each team to consider setting work priorities, taking into consideration which items need to be purchased from the very beginning and which items can easily be bought off the shelf, so to speak. Bought off the shelf, meaning that those items are readily available, versus items that you have to purchase ahead of time, and take into consideration that when you purchase an item ahead of time, does it have all the necessary items needed for you to make this competition a success? Yeah. If it does not, that is where you assign your subsystem tasks and your activities along a timetable to ensure that you have everything managed.
And the key point here is developing a credible schedule is very important. It's critical to the success of your project. Next slide, please. So these are the key terminology for the projects. I'm not going to go into detail. I just wanted to put it in one slide, all the details. We're going to be talking about the different task sequence, activities, milestones in greater detail throughout the presentation, but that's kind of gives you a glossary of all the key information. Next slide. So the first thing that I wanted to highlight for you is the work breakdown structure. Now, this is widely used in the project management as a discipline, but the use of the work breakdown structure depends on the complexity of the project. And when you're building a satellite, when you're building an actual rocket, it's very complex. It's thousands and thousands of parts that you need to either fabricate, machine, procure. So you need to have a way that you can break down in different tasks and different activities, work packages, and some of those work packages might be done by different companies, different vendors. So the WBS is a very good tool. In this case, for the first nation launch, your project is fairly simple. So this might not be directly applicable, but I didn't want to not to mention it, because this might be good for further in your career or maybe a future project that you're involved. Next slide. So this is just an example for a project that I led several years ago. We were building a whole satellite. It was part of the Living with a Star program. The satellite was called the Solar Dynamic Observatory. And here you can see the different, I had my project management team, the spacecraft, all the different activities, all the different WBSs on their spacecraft, so I can track the cost, track the schedule of them, and successively. So if you go to the next slide, please, then you can see an example that you have the spacecraft is 2.0. That's the WBS 2.0. Then it's broken down into many elements. I just took an example. 2.11 is the mechanical. There I have the people that are responsible. The design lead, it was called Giulio Rosanova. He was the lead doing that. And the responsibility was to create the carrier system and the subsystem products. And then you further down breaks in the responsibilities. 2.11.1. You can see that those are 3 sets of numbers. That's a level 3 WBS. Then you have engineering, hardware, equipment. Then we use those things to develop the cost and develop the schedule. So this is just an example of how do you use a WBF.
And that is absolutely right. So this is for a very complex and satellite development. So you can see just the complexity of managing something at a very large scale. But for First Nations launch, you may not go to the level of detail because it's a smaller project. However, you have already been taken roles into the development of each subsystem. You may look at your booster section and you may list all the key elements that are needed for your booster section to be complete, or your payload. Have you taken into consideration and listed all of your key components that are needed and the key personnel that are needed to complete your payload? And so you may use different elements of a work breakdown structure for your First Nations launch, but it may not be as complex as the one that is presented.
Next slide. And I think that Orson was talking about setting the stage for this slide, planning a project and creating the schedule. First, you have to plan the project before you create the schedule. And these are the steps in gathering the project information. Just like, we have been saying, set the goals and objectives. Orson, highlighted list of tasks that you need to do. And then start estimating the duration, how long it takes for me to put the order and wait for the equipment to arrive. That's a critical, duration. What is the sequence of things? What are the things that we need to do first? What are the things that we need to do last? So again, scheduling those things, those are essentials. And I think that Orson gave you a good overview of how this relates to the First Nation launch. Next slide. So defining the project, one of the first things that we wanted to describe is a milestone. What is a milestone? A milestone basically is an important event that signifying the measurable progress toward achieving your goal. Say, for example, let's pull making a procurement. You're going to buy some equipment. Well, what are the things? You're going to find what are the parts, what is the cheapest price, or what are the requirements that you need to meet. And then you say, well, I'm going to place the order. Placing the order might take just only a few minutes, but doing the pre-work of placing the order might take some time. And then you have to wait until it's delivered. Who knows? If you buy it from Amazon, it might arrive in 2 days. It might take a little bit longer, depending where you acquire. So these are activities. At the end of those tasks, then a milestone, an example of a milestone we see will be complete procurement and parts arrival. When you finish the procuring and when you have the part in hand, you can say, I completed that milestone. Those sets of activities, that's how you use milestone. That milestone has no duration, but it gives you, it indicates that you completed those sets of activities prior to that. So why do you need milestones? For example, we talked earlier by Orson that you guys already had completed your preliminary design review. That's a milestone. Yeah. So the next milestone might be the critical design review. So you can put critical design review, that's a milestone. What are all the activities that you need to do in order to complete that milestone?
That is right. And so one of the things that you all have useful is your student competition handbook, right? Which lists all the key components that are needed for your critical design review that is coming up. So here you have an opportunity to look at the scope that is needed to complete a successful CDR, and you look at all the activities and the tasks that are needed to accomplish what is needed to be presented at CDR. So you can start to take a look now to see what items you need to meet as a team together to meet those milestones from now until your CDR, and even for your flight readiness review and even for launch day review. So you can start to take a look at what kind of milestones as a team can you put together from now until then.
Next slide. So continuing with that, once you break the project and in this case, your Moon Engineering Challenge or your Mars Engineering Challenge, once you have the task that you want to accomplish and your milestone, then you have to scope the project first. Create a list of the tasks, and this is a good opportunity to mention. You need to rely on the knowledge and experience of your team. There might be members of your team that have gone and participated in previous competitions and previous activities. So you need to leverage the experience of those members or staff, advisors, projects advisors, professors are advising you, student advisors, how can you do these activities? And then you break them down into the task, into the events that you need to do, how long they will take, when do you need to accomplish them. Normally, I'll recommend when you say the bottom bullet, defining the task. I like to do it two ways. I like to do a top-bottom approach. Top-down, that means that you basically, from your knowledge, what are the things that you need to do? And then do a bottoms-up task. Okay, if I have all these things, how do I assemble it to achieve my goal? In that way, when you do a top-down and a bottom-up, you make sure that you catch things that you may have forgotten. So again, basically, leverage your team knowledge and all the people contribution from your team.
That is absolutely right. And this may seem very complex for, let's say, a First Nations launch rocket kit, but if you take a look at the picture to the right on the screen, it says consider using note cards or post-its to visualize. It can be as simple as just putting things on the board and working as a team to start to organize which items belong where, and therefore you can start to divide the task and the necessary personnel or identifying the experience that is needed to complete those tasks. And so you can start to take this type of approach to consider using a board, using a whiteboard.
Yeah. So just a spoiler alert. So at the end, we're going to give you information in terms of what are some free tools as a project management tools to do your schedule. But before you jump into doing your schedule, these are preparing activities that we have recognized the value of it. Anybody can go and start typing things on your schedule, but how reliable is that schedule? How realistic it is? You want to do the steps first. Use sticky notes and all that to identify your step. Once you agree these are all the steps, then you can capture in a more structured way. And we will highlight that as we go. But so you can see that the goal of my presentation is to create the building blocks, or once you start using your computer, you can use it in the most effective way. Next slide. So here I wanted to give you some do's and don'ts for estimating the duration of the activities and the tasks, because this is very important. If you underestimate an activity, that means that you'll never be able to complete it. So you want to apply realistic estimates. You want to consider the task interdependence. You want to first do them independently, but then later on, do I need to do this first and then follow by this? Can I do them in parallel? How many tasks I can do at the same time? How many people? Are you measuring in hours or are you measuring in days? Well, it depends on the complexity, it depends on the activities. A procurement, you may want to measure in days and let the computer transfer it in hours. But if you're assembling something, you may want to say, well, it takes 4 hours to do this and 2 hours to do that. It will be a total of 6 hours. If you assign a 1 day and you're assuming that 1 day is 8 hours, you build in inefficiencies because you're basically overestimating your project. So you really need to be able to be conscious about those things. Some of the don'ts are very important. You don't forget to consider your resources availability. Say, for example, if part of my work is going to be done by Orson, and I don't ask Orson, what are the days that you're available? And if he has to go and travel, well, I need to schedule those activities that Orson is going to do, in a time that he's going to be available. So that's why you need to look at, I say everybody, check the team. Hey, when are you going to take exams? When are you going to have projects? When are you going to go in spring break? All these things you need to take in consideration, because you could do a perfect schedule, but if you don't take availability of your team into consideration, your schedule is going to blow. It's not going to be able. So don't forget about your finish date. It's important to make sure that you are ready for April the 24th, but, don't wait until the 24th. Plan to, finish a week early, 2 weeks, whatever is the case. You want to work with your team and give some, what we call slack, some time available in case things go wrong. And believe me, there is a potential for things to go wrong. Nothing goes perfectly as planned. So you have to, a smart project manager or smart team leader plans for those things to happen. Next slide. So again, we're talking about the sequencing. When do you do things first or last? And maybe Orson has some advice here, since you have gone through some of these activities.
Yes, talking with what Juan just mentioned about estimating tasks. April is around the corner. We have CDR coming up in March. You're going to have certain expectations to meet for CDR. In this particular case, your motor selection and your final design for what you're going to do for your payload, and all the assemblies that is needed, and the plan to put that together. So taking into consideration the realistic estimate, the realistic time of putting and accomplishing these tasks. What items need to be done from now until then, and prioritizing them to see which ones are needed to be done, and the task that is needed and the constraints that are around that task is, running your software for your mission performance simulation to determine which motor you're going to use. Do you have everything needed for that simulation to be complete? And if you don't, what factors are needed for that to be complete? So sequencing your tasks is more about, I would say, priority, priority management, and the time that it takes to complete those priorities, and the realistic time that it takes to finish those priorities or meet those priorities. Because if you're meeting, let's say, once a week on Wednesdays, and all of your team members are working 12 to 16-hour credits for your college, meeting once a week may be the only time, but what are you going to accomplish within those that time frame?
It's very important. So sequencing, we'll go into more detail on the next slide, because it's a pictorial. One of the things that you need to consider for sequencing is when do you start the task? Next slide, please. So you can see, and I'm going to just highlight a few because time is of the essence here. We're running. Finish to start. Basically, task B cannot start until you finish task A. And those are the things, just like Orange said, you have to run the simulation before you can proceed, fabricating or making some commitments. There are tasks that you need to buy, that you need to complete both of them at the same time before you're proceeding. You buy some equipment and you get some tools. You need the equipment and the tool in order to take to the next step. That's the next one, finish to finish. You need to finish 2 activities in order to proceed to the next one. Some other tasks are called, start to start. That means a task that you can do in parallel, and you want to start at the same time, but then you can't finish one until you finish the other one. So these are all relationships. Again, for the FNL, First Nation launch, these are fairly simple, but I just wanted to plant the seed so later on you can see how all these pieces fit together.
So as an example, for preliminary design review, one of the requirements was presenting a preliminary design for your payload system. For the Moon Challenge, it was how are you going to secure the egg safely? Now, you may not have a well thought out plan, but you started to initiate the process as you were considering which rocket kit to use. So this would be an example of starting two items in parallel, but not and having them be completed at a certain date. So you can start things, but the only way that process can be initiated is if you identify the task, the people that are needed for that task, and the estimation time to complete that task. So you could probably work on your avionics system along with your payload system while you're waiting for your rocket to be delivered.
Yep. Next slide, please, because I think that captures what Orson was saying also in terms of assigning people, equipment, and cost. You know, so assigning the people who's going to do what is very important, as we have mentioned prior. What are the resources that you need? Do you need a lab? Do you need to separate a conference room, you know, to meet? Where are you going to assemble this? Are you going to do some testing throughout this? So there are all kinds of things. Don't forget about them. The equipment that you're going to need. Do you need to put all those things together? Sometimes it's better over plan at the beginning, because if you over plan at the beginning, then there is a possibility, a higher possibility that things go smoother, other than trying to, you know, run, you know, in a semi-chaotic environment. Believe me, I have been in multiple teams, and teams takes a life of their own, and sometimes they could be very chaotic or they could be very structured. So we aim to have a structured process.
And one of the things that we, for FNL, is utilizing your entire team, because every single person in your team is important because they play an important role or a vital role into the success of your rocket development. So in this case, you know, maybe there's some individuals that are really skilled with the painting or the gluing for your rocket. And there are some other individuals that are really good with scheduling everybody and meeting with everybody and organizing everybody. Every single person is important, and so it's important for the teams to understand that up front, even starting now. If you haven't done this level, you start considering now and start outlining your plan forward to when your rocket arrives, putting all the pieces together and listing the components that are needed, but also which people are going to be responsible for the items that are going to be delivered.
So next slide, please. So right now, again, in case of cost, and I don't know exactly, you know, if you have any cost limitation and any cost constraint, but at least in your professional career, when you have a project, they don't give you an infinite amount of money. So you need to take in consideration what is the cost of the people. If you need to hire somebody to do something, if you need to buy an equipment or you need to rent an equipment, how are you going to do it? How are you going to calculate those costs? Well, that depends on how you break down your project and how detailed is that.
I would say also assigning resources. It could be as simple as, do you have the proper resources to write your report?
That's correct.
Because if you're doing all the work and it's now time to start documenting your process and documenting your report, you know, do you have the funding to purchase your Microsoft software? That's an example of you just taking into consideration your resources that you have available and what resources are needed.
Next slide, please. So here we're talking about managing the project. Now we have kind of built the stages in terms of the task. We have talked about milestone. We have talked about the resources. We have talked about multiple things. Now, why do you need computers? Computers can do calculations really, really fast, much faster than we can. So the goal is that you have all the information, put the information in the computer. In this case, it's a Microsoft project is an example of a project management tool to calculate the critical path, calculate the activities, and it gives you a visual representation of the projects, the activities, and you can see the graphic on the right-hand side, how you can see what activities are done in parallel, what activities are done in a serious mode. That means that you have to finish one in order to process, to go to the next one. And it I want to introduce another topic. It's called the critical path method. The critical path is very important, and the computer can calculate it really quick. Critical path is defined for what are the sets of activities and tasks that takes the longest, because your project will take as long as the longest set of activities. You know, you can finish a bunch of other things, but they are not going to be allowing you to finish the project sooner because there are other set of activities, and we'll go into more detail later. But this is a tool that was developed a long time ago in 1958, and project managers use that very effectively because you need, and my advice is you need to keep an eye on the critical path. Next slide. So why the critical path is important? We already started to do that. That if you delay, if any set of activities, say for example, procuring, buying your rocket kit, or selecting your motor, that's a critical thing. If you don't select it, then it's not going to fly. And if you delay and you stretch that selection, you know, a month or 2 months, you know, I'm exaggerating, obviously, but what happened? Your total project is going to be delayed for that same amount, unless you can recover that time doing something else. But, you know, that, for example, one of the things that I advise teams not to plan to work over the weekend. Plan your projects working 5 days a week, Monday to Friday. And then if you run into trouble, if you get delayed, then you can say, well, maybe who can work on Sunday? Maybe we can work a little bit on Sunday, or maybe we can work Sunday and Saturday for those who work. You know, it depends. You develop workarounds, but your critical path is a set of activities that are going to define from beginning to end, and you need to keep an eye on it. Next slide. So this is a brief example of activities. You know, these are the laser X subsystem. Can you find the critical path? And you can see these are a PERT chart that shows different activities. You know, define the laser requirements, take 20 days. Refurbish building 2 laboratory for the laser. That's 120 days. And then you look at other activities. So I'm not going to waste time. You know, you can calculate, and I tell my students to calculate and tell me no. Next slide. The critical path in this activity is the first one. So that path between defining the laser requirements, you know, refurbishing the building, performing the checkout, et cetera, until you write the final report. Any delay in those sets of activities are going to delay the final project. However, you know, you may have the next activity is design, build the laser, which is 100 days. If you neglect that activity completely and it keeps growing, and it grows before more than 125 days, then your critical path will jump to that one. So again, that's how you use your critical path.
So in this example for the laser X requirements, the critical path was the facility. So, you know, participating in First Nations launch, you may have identified, you know, your best rocket kit to meet your altitude. You identified your payload that you want to use for your Moon and Mars challenge. But if you don't have the facility to design that and to fabricate it, your critical path would be your facility. Do you have the necessary resources available for you to meet your objective? And which resources are dependent upon, let's say, your facility that is needed? Your entire rocket kit is dependent upon your facility. So that is just an example of you identifying key components that could hold up the build of your rocket.
Next slide, please. So here we're trying to give you now at a higher level schedule management. Why schedule is important. We have mentioned that, you know, it's a great tool to keep the project planning and control going forward smoothly. You know, you can use the critical milestones that you have identified and the completion of those milestones as reporting. say your advisor, your team advisor might say, hey, how your team is progressing. And you can say, hey, we have completed this milestone, this milestone, this milestone. It shows the people that you are working that you are making enough progress and you are on schedule. That means that you're on track to meet your goals. But the schedule is as good as your expert judgment. That's why we told you, use your advisors, use the people within your team, that have gone through the process before, and then leverage those things in addition to what your computer says.
Yes, and I think that right here is your student competition handbook is a resource that outlines, yes, your schedule of major components that are needed, but you can start to use that as a guideline to start setting your schedule moving forward. Because if you have a good schedule, it's a wonderful tool to have to manage the entire team, but every key component of the rocket build. So here, utilizing and managing your schedule according to what needs to be delivered. For PDR, you delivered certain criteria, you met certain criteria. Now you have the opportunity to look ahead for CDR. What items are needed for CDR? And from there, you can start to drive your schedule and identify certain milestones that are needed so you're not up, let's say, up until midnight trying to work on your report and trying to get every piece together, and you're up late at night and your other team members are unavailable and you're by yourself doing the work. If you can start now to start managing key components of your CDR requirements, it will save you a lot of effort moving forward.
Yep. Next slide. We also covered the content of this slide, but I wanted to highlight that it's not only the internal milestone, but also there are some external milestones, some like we have already mentioned, reports and activities that you want to be able to take in consideration. I will advise you to include those external factors into your schedule so you don't lose track of them.
I think for here also, I could be monitoring the weather.
That's correct.
Snow days, there's projected snow days moving forward. I know last season, a lot of schools, had to cancel their team meetings or their virtual reports because there was a snow day. I know we can't always predict
the future or control
the future, but we can look at the forecast to say, okay, then there's severe weather coming up. What are my workarounds and how can I start working around that?
And we'll talk a couple of tools that I would like to recommend at the end so you work effectively in your team environment. And maybe sometimes, hey, you have a mission and maybe you don't have a snow day, you don't have classes, but maybe you can still collaborate virtually in using other tools so the project continues. Next. So very briefly, I just wanted to give you an example of what does a schedule look like. The critical path is showing red. The schedule reserve is in green. When we were talking about, when Orson was talking about, snow days and things like that, they are outside of your control. That's why you have some reserves. That's why you have a few days. Oh, I can do all this work, but let me put a few days here in reserve just in case something happens that I have no control over it. Next slide. So this is another way. We were at the slide where we had the PERT chart. So yeah, so the PERT chart is another schedule way to visualize the schedule, basically. Some people like the PERT chart because it just shows you the sequencing, the logic a little bit more, but again, it's one or the other one. I will not go into detail. I don't think that it's really relevant for the First Nation launch, but just show it to you because you may use it in the future. Next. So I want to basically identify or mention that identify, analyze, plan, and implement are the key pillars of good project management. You need to identify the activities, analyze, and consider all type of aspects that you need to take in consideration, including potential risks or issues, plan for them, and then implement your project, implement your schedule that you have developed. I want to highlight not only plan for the bad things, because we all know that people get sick and bad things happen, but also opportunity management. There are ways that if you see an opportunity, if you see somebody, for example, that can provide you advice that can help you, don't refuse help. Those are good things that can happen. If somebody brought you help, or somebody, or you accomplish a task much faster than you anticipated, just celebrate those good moments and continue forward. Don't just say slack off. Sometimes people say, oh, we did this and it's great, we did it on the time, let's party. And then you just like not take advantage of the good things that happen. Next. So again, what to look in a project management software. Basically, you want to establish a baseline and then keep that baseline and have different revisions. Maybe you can say version 1, version 2, milestones. You can track the milestone to see how did the project progress and what are the lessons learned. This might be a good, I think that overall as educators, we want you to have a good time to learn, but also as part of your professional career, look back after you complete this activity. What were the things that went right? What were the things that went wrong? If you had the opportunity to do them again, learn from them. That's a process that we all have, and we take advantage of it. But again, create a dynamic link between the people and the project, not only through the software, but also leverage on friendship, work together, leverage each other. I think that those are important advice.
No, yeah, I agree.
Next slide. So that's going to be our last slide, and we are going to have a few minutes. But I want to give you some helpful collaboration tools. Google Suite. Many of us, use Google, email. But in addition to the email, Google Share Drive, Google Calendar, photos, take pictures of your project, different stages, so what you can use it in your presentation or your reports. You can use Google Docs. So everybody will be working on the same document, and you can see the edits that somebody did. You can correct, Google Sheets, Google Slides. There are a lot of tools that you can, and these are collaborative tools that you can use, and you can use it from anywhere. You could be on travel away from your university, and you can still put aside a few hours and collaborate with your team. The list on the right are project management tools. These are project managers, project work. These are project management software that you can download and use for free. I went and I did a search. These are the 12 best free project management apps. So you can use project management, like for example, Microsoft Project, that is part of the Microsoft Project suite, but it doesn't come, standard in every suite. But you can go and look at each one of them. If you highlight, once you get the presentation, you can click on each of those names. Say, for example, Trello or MindShare Task, and it just explains what that does for you, and they're all for free. So take advantage of those free tools if you can. So with that, we have done this fairly quickly between Orson and I. I thought that this is a team presentation. I want to leverage the knowledge that Orson has. He's a colleague, and we wanted to give you this as a resource. We wanted to open it for questions for the last few minutes. And I'm willing to stay a little bit longer if needed.
This has been a
So, yeah,
fantastic presentation. Thank you. So let's open it up to the team. If you have questions, feel free to ask. You may have to mute your mic while others are talking and then going back and forth. My apologies, Orson. So does anybody?
So let me.
Or I don't know if you had two going at the same time, if that was maybe, if both computers are going, and that's why we're getting a little bit of the feedback.
Okay, so can you hear me now?
I can hear you, and now we don't have feedback. Excellent. All right, so let's open it up and see if anybody on has some questions or comments.
Don't be shy. I'm not shy person, so.
Hello, Orson. Dr. Roman Marchand Vasquez here with Salis Kootenai College. I just want to thank you guys for your time and your presentation and all the knowledge you guys gave us. It's really helpful, and I hope to implement a lot of this information you guys have showed us. But yeah, just thank you for your time.
Welcome.
Thank you,
And we will, it actually already is available, the presentation. It is on the FNL website under tools and tips. And so we do have the PowerPoint there now, and then I will have the recording afterwards as well. Does anyone else have a question or comment? You may also send myself a question, and if we do have any questions that we receive in, we'll put together an FAQ page and then send that back out to be able to answer the questions for you.
Yes, great. Another thing that I want to, there are more slides that I put in the backup. There are the top 10 guidelines and let me see what I call them.
10 rules.
Yeah, rules for project management. I think that those are good resources for you to consider. You know, if you want to know more about, you know, these are like based on my personal experience and other people's experience. What are the key things that you need to keep an eye, keep the eye on the goal? So I just put a little bit of extra information there.
Yeah, I think some of these are excellent tools for students and anybody else on the line. So excellent.
One of the things that I want to wish everybody good luck, work hard. I think that this is an exciting project. I was talking to Orson, and the winning team are going to come. They're going to go to NASA Kennedy, but also they're going to come to Wallops Flight Facility here, part of Goddard Space Flight Center. So I wish that we could, you know, meet some of you that are participating. I'm planning to be there as part of some of the activities that they're going to be scheduling.
Excellent, and we can make sure that we make that work. Well, very good. I think that it doesn't look like I see anybody. Tonalisa, I see you came off mute. Did you have a question or a comment? All right, then. I do want to thank everybody for attending. Thank you, Dr. Roman, for your presentation and just your excitement and enthusiasm. We appreciate it as a program, and just thank you for kicking off this series. Really excited about the potential this has for our students and how it will help not only with this project, but in future projects and potentially in their careers afterwards. So thank you very much.
Welcome.
Thank you. Thank you, Christine, and thank you to the students and the advisors and the rest of the participants.
For the two of you, there is a note, and it does say, thank you very much for the presentation and for putting this together. It was well received. So.
Oh, okay. Okay.
Okay. Thank you, everybody.
Thank you. Bye-bye.